Assalamualaikum warahmatullahi wabarakatuh and a very good day. We are from group number 25 and our project is the multifunctional magic walking stick. Firstly, I would like to introduce our team members. The first team member is Angappan, the second member is ESTY, the third member is myself, HALIZA, and the last member is KANAPATHY. The supervisor for our project is Dr. Jeffrey bin RAZAK. I would like to start the presentation with the abstract or the overview of our project. The project execution has developed several design concepts of a multifunctional magic walking stick through a systematic process. The design should ease elderly in their daily activities. Throughout the project, we have covered the shortcomings, requirements, and measured the efficiency of the design concept. The theme for our project is Innovative Solution for Community Application. We decided to design a multifunctional magic walking stick to assist elderlies in their daily movement. Not only that, our focus is to improve limitations and concerns of customers in existing designs of a walking stick. Now, I will pass the presentation to the next presenter, ESTY. Thank you.
Assalamualaikum, my name is ESTY and I will continue my part starting from the problem segment. What are the problems encountered that we have to develop this project? Let's take a look at this timeline. Most of the elderly experience postural problems, so they need any assistant aid to support them, for example, walking stick. But here comes the problem whereby the current use of the walking stick is somewhat limited to only one function. Hence, we incorporate various features that is useful for the user. Firstly, our target is to design a multifunctional magic walking stick. Then, to analyze user requirements through survey and interview. From the output, we further proceed with analyzing design feasibility using various tools such as DFM, HOQ, and more. Here's our project scope, is to incorporate features such as LED torchlight, adjustable height, anti-slip pivoting base, foldable chair, and we have to work on the market survey and interview session. Move on to the next session, which is on literature review. According to Chen, the percentage of the elderly will be increasing up to 74 million people by 2040. Shai claims that older people are at higher risk of falls compared to the other age groups. By that, Lechta and Wall tells us that it is beneficial to provide the elderly with any support aid. What are the strategies used to innovate our product? Here, we integrate two tools, which are competitive benchmarking and pattern search. What is benchmarking? Benchmarking is we take the sample product from any successful organization and we compare their ideas to our own ideas so that it can improve our product's quality. Normally, we utilize this benchmarking at the conceptual design phase so that we are still able to improve the design. Next is pattern search. It is used to differ the invention made of the current existing product and invention made to our product, but still both of it remain its originality. Okay, this is the first patent by Paul 2014 that invents a folding walking stick chair. The purpose of this product is to help the elderly walk with a walking stick and rest after a certain amount of time. The second patent is by Birnbaum 2017 that creates the design for an ergonomic walking stick. Ergonomics is a valuable aspect in design to give more comfort to the user. Next is Wu that invents rubber ferrules, adjustable stick height, and elastic grip attached to the grip handle. We devised this invention to improve it and include it in our product design. Always, reviewing concept is a good idea. I guess that's all from me and I will pass the next session to HALIZA. Thank you.
Hi, we meet again and I will be presenting on the methodology where we apply various analyses to achieve the purpose of our project. The first analysis is House of Quality, HOQ. It forms just like a house and it comprises of customer requirements, technical requirements, correlation matrix, relationship matrix, competitive assessment, and technical assessments. All of the components were obtained from market survey and benchmarking. In this analysis, the relationships between the components are measured. Second analysis is task analysis. The purpose is to integrate human factors engineering in our product. This will enhance the interaction between the user and our product. To do so, we identify requirements taken by the user to achieve their intended goals. We observe the task and validate the task through interviews. Then, we will be able to extract design requirements that will allow the product to increase human performance. The next analysis is Design for Manufacturing and Assembly, DFMA. It combines two analyses, which is Design for Assembly, DFA, and Design for Manufacturing, DFM. Design for Assembly, DFA, reduce the number of components that will reduce assembly time and increase the design efficiency. Design for manufacturing (DFM) will ease the manufacturing process by selecting the most appropriate process that will not break the bank. We also incorporated Design for Environment (DFE). The purpose is to reduce the environmental impact of our product. We apply DFE guidelines such as to consider multifunctional design for efficiency, reduce number of different materials, and reduce fussiness. That is all from me. I will pass the presentation to the next presenter, Angappan. Thank you.
Hello, my name is Angappan. I will present the result and discussion for first 6 points. Number 1 is market survey. What is market survey? Market survey is mainly to get response from the public about our product design. Firstly, we have created a market survey using the Google form. Secondly, our targeted people are old and elderly person who require a walking stick, and we try to collect their experience in using the walking stick. Thirdly, we were able to obtain the feedback on the walking stick from 53 people using this Google form. And lastly, the majority of them are agreed to design a multifunctional walking stick to replace the existing walking stick. This is because some of them have faced some difficulties using the existing walking stick, mainly because the existing walking stick is limited to its function. This is our proposed design in the market survey Google form. Number 2 is house of quality, HOQ. What is house of quality? House of quality is a chart that appears like a house and is used to explain the relation between the user's demands and the product's functionality. From the market survey result, we were able to develop this house of quality chart. For this product, we integrate 9 customer requirements such as cheap cost, multifunctional, user-friendly, ergonomic, safety, and also 9 technical requirements such as minimum cost of production, comfortable design, additional features, minimum number of instructions, and more. Every requirement has their own relationship with each other. During developing this house of quality chart, we were able to benchmark 4 companies that manufacture the walking stick. Number 3 is task analysis. Task analysis is a crucial step in creating a satisfying user experience. There are 6 steps in task analysis. Number 1 is identify task to be analyzed. Number 2, break down this goal into the subtask. Number 3, draw a layered task diagram. Number 4, write the story. Number 5, validate our analysis. And number 6, extract the design requirements. Next, the study participants. The participants is interviewed via face-to-face or phone calls. We are able to select 4 different types of walking aids from the interviewer to conduct this task analysis. From this task analysis, we get more knowledge about the user satisfaction in detail on using different types of walking aids. Number 4 is tree structure. The tree structure can be used to demonstrate an understanding on the components that make a product. This is the tree structure of original multifunctional walking stick that containing total of 63 components in 5 levels of branch. And this is the tree structure of new multifunctional walking stick that containing total of 31 components in 6 levels of branch. Number 5 is concept generation. For the concept generation, we are using morphological chart. This morphological chart may offer numerous ideas or concepts to the problem, but not all these solutions are beneficial. This morphological chart demonstrates the solution and sub-function that we have chosen for the multifunctional walking stick. Concept evaluation is taken place once the multiple concepts have been developed, and the generated concept must be reviewed in order to identify the best concept from the multiple concepts. From the morphological chart of the walking stick, we are able to sketch 3 different concepts. From the developed concept, we have performed screening and scoring table for each of the concept. From the end of this concept evaluation, we have chosen the highest scoring concept, which is concept 2. Next, I will pass the presentation to Kanapathhy. Thank you.
Hi, my name is Kanapathhy. Now I'm going to present the rest of the result and discussion part. In this project, we have created a bill of material for both existing and new design of the multifunctional walking stick. The purpose of developing this BOM table is to identify the total number of parts, material cost, and the total cost of the walking stick. The left hand side table shows the BOM for the existing walking stick, and then the right hand side table shows the BOM for the new design of the multifunctional walking stick. Based off the BOM table, we can estimate the total price of the existing walking stick is around 326 ringgit, and for the new design around 313 ringgit. Next, I'm going to present about the design for manufacturing and assembly. DFMA is an engineering approach that prioritizes product part simplification and improve assembly into finished good. There are 2 types of manufacturing technique under this DFMA part, which are the design for manufacturing and design for assembly. Firstly, the design for manufacturing is a method that emphasizing on material selection and designing for an easy manufacturing process. Thus, we need to identify the material for the each part and figure out the most suitable manufacturing process to produce them. Next, the another manufacturing technique under DFMA is design for assembly. Design for assembly is a method of lowering product pricing and assembly time by reducing the number of parts and the assembly process. Using this DFMA technique, we completed the Wiltrud table for both existing and new multifunction walking stick. From this table, we can see that the number of parts is reduced from 63 to 15 and the total operation cost is reduced from 213 cents to 86 cents. Next, design for environmental is a technique to minimize the environmental impact of the product manufacturing and service. In this project, we have reduced the number of parts approximately 50.79%, which will result in a significant time and resource saving during assembly. For example, we have reduced the number of screws from 8 to 4 and the number of parts to 10 to 5. This will directly improve the design efficiency of the walking stick and also reduce the environmental pollution. Next, the detailed drawing and the exploded view of the new design of the multifunction walking stick. So this is the CAD drawing of the foldable view, unfoldable view and exploded view of the new design of the multifunction walking stick. Then, the limitation and challenge during developing the walking stick. As we all know, that the COVID-19 pandemic is a primary problem that we face during developing this project. This is because since the COVID-19 outbreak, we are instructed to follow up online classes. Thus, we cannot interact as easily before and we need to use online platform to discuss with our project group members. Apart from this, we have to rely on Google information only since we cannot access to library books or other resources. As a conclusion, we have successfully developed the new design of the multifunction walking stick using various research and developing techniques. From this, we are able to design and develop a product in near future that can be environmental friendly and helpful to people as well as make their life better. That's all from us. Thank you very much.